Okay, so in this video, we will look at the second electrical test, which is a partial discharge test, or commonly or simply called PD, right? PD test, very common in the electrical system in the industry to perform PD tests. Okay, so what is partial discharge? What is PD actually? Um, PD is basically electrical discharge. Okay, discharge, electrical discharge or electrical spark that bridges small portion of the insulation between two conducting electrodes. We have two electrodes. Okay, in between we have the insulation. Okay, similar to the previous video about tan delta, we have two electrodes, two conductors. In between we have insulation. To test the insulation material, we perform tan delta test, and also in this case we can also perform partial discharge test to evaluate, to assess, to monitor the condition of the insulation. All right. um, so um, the insulation between two conducting electrodes, when there is an electrical discharge inside the insulation, then we call it partial discharge. Okay, partial discharge activity, right, inside the insulation. So PD activity can happen at any point in the insulation system, right? Can happen at any point where the electric field strength exceeds the breakdown strength of that portion, or that location of the insulating material. Okay, um, and then PD can occur across the surface. Okay, not just inside the insulation, but PD can also happen across the surface, on the surface of the insulating material. Okay, usually it's because of contaminants. Okay, contaminants on the surface, um, such as conductive contaminants, such as water droplets on the surface of the insulation materials that can cause partial discharges, right? um, so besides the surface of insulating materials, partial discharge can also occur in gas bubbles. Okay, gas bubbles which exist inside the liquid insulation, right? For example, transformer, we use oil for the insulation, and somehow when there is a gas bubble inside the oil, partial discharge can happen in these gas bubbles. All right. Also in voids within solid insulation, we have solid insulation, such as in insulation of roto, or sorry, insulation of stator of rotating machine. Okay. Solid insulation, we have voids in the solid insulation. Voids is basically air pockets inside the solid insulation. All right, you probably during the manufacturing defect. Okay, so there's a void or air pocket inside all the solid insulation, and because of that, partial discharge can happen in the void. All right, and not just the void in solid insulation, PD can also occur around an electrode. Okay, around an electrode in gas. Okay, so this is usually called corona. All right, very popular term now, corona. So we have virus corona, we also have electrical corona. Okay, as an example here we have several pictures. So this is electrical, this is tracking, treeing. Basically partial discharge happens on the surface of the insulation, and then on the top right side we have unwinding surface discharge happens on the stator winding of a generator. So this generator is a large generator. It's an 15 kV generator. So because of that high voltage, partial discharge happens on the surface of the stator winding. You can see from the white powder, the build up of white powder on the surface. And on the bottom left corner of the screen, this is instrument transformer. Okay, so picture of instrument transformer. So on the left is there's a PD happening on the surface of the voltage transformer. So this is one phase of the voltage transformer or instrument transformer connected to the bus bar. Alright, so the PD happens on the surface, alright, only on this phase, not on this phase. So uh, there could be a reason why this happens only on this phase, but you can see here this is the result of partial discharge. Okay, it's not completely breakdown yet, but the discharges, okay, the partial discharges is happening, and we have to solve this problem before it becomes full breakdown, complete failure, right? And on the right side, bottom right picture, this is taken from overhead line. Okay, we have string insulator. This is the conductor, it's the live conductor, and then here we can see the corona. Okay, so corona is electrical discharges happens on the surface of electrode inside gas. So this is the electrode inside the air. So the PD occurs here on the surface of the electrode. This is called corona. We call it corona. Alright, so these are the common types of partial discharge. So this is the insulation. This is the insulation, solid insulation. Ground. This is the grounded electrode. This is high voltage electrode. So partial discharge happens on the surface. Okay, surface of the insulation. And this is corona discharge, meaning that the electrode is in the gas. Okay, so we have partial discharges happens on the surface of the electrode inside the gas. So that is corona discharge. And then here we have internal discharge in laminated material, meaning that um, this is the electrode, high voltage electrode. We have gas, and then we have the solid, and then we have the grounded material. The grounded electrode. So that when the partial discharge happens in these arrangements, it is called internal discharge. Okay, laminated materials, laminated. Okay, laminated with different layer of solids, different layer of insulation. All right, and then this is cavity or void. Okay, void discharge. We have solid insulation, and inside the solid insulation we have air pockets or void. All right, so the discharge happens inside the void, right? Also, this is a typical problem with cable, high voltage cable, right? So we have conductor here, live conductor, high voltage carrying conductor carrying current, and then the outside of the cable is grounded. So in between these two electrodes, we have electrical treeing. Okay, it's common in high voltage cable. All right, so let's look at the idea, the theory of partial discharge. We know that partial discharge happens in insulation between two electrodes, right? So here we have two electrodes, electrode A, and we have electrode B. Right, in between is the insulation. which in this figure we represented with um, series and parallel of capacitance. Okay, so here you can see here, this is the void. Okay, this is the void. So the void in this case is represented as one capacitor. Okay, the rest is represented by different capacitor. Why a different value of capacitor? Because different insulating materials has different permittivity. Okay, we know that capacitance depends on the permittivity of the insulation material, right? Capacitance depends on the permittivity of the insulation material. So solid insulation permittivity is different with the air. So that's why the value of capacitance is different. Okay, so we represent it with in this case Cp over 2, the same Cp over 2, and this is 2Cs, and this is Cf. Okay, so epsilon r is the permittivity of the solid insulation here, and then this area is the void, the cavity or air pocket, represented by permittivity or epsilon 0, which is the permittivity of air. Alright, so when we supply high voltage potential, alright, between these two electrodes, okay, what happens is that because of the voltage is high, and then discharge will not happen inside this insulation, but because of the uh, electrical strength, the strength of the insulation material. However, if we have air pocket, air is not very strong insulating material compared to solid insulation, right? Because air is just a gas. Solid has more strength in electrical breakdown. So because of that, the breakdown or electrical discharge will start from the air. Will start in the void here first. Okay, so you can see here, you can try to understand here. So this is ut. Okay, so this ut is the voltage across this whole insulation, this complete insulation. Voltage ut is the voltage across this whole insulation, right? And then u1 is the voltage across the air pocket, across the void. Okay, across the void, u1 is the peak of u1, or the magnitude or amplitude of u1 is much smaller than ut, because ut is the u total. So u1 is the voltage across the air pocket. So it is actually some part, okay, a part of u total. All right, so this is the voltage across the air pocket, and because of the air pocket, okay, the electrical strength is weak in air pocket, right? Because of that, when it arrives at a certain value, for example uz, discharge happens. Okay, when I say discharge happens, means that there is an electrical breakdown inside the void. Electrical breakdowns means that there's a current flows. Now current flows inside this air pocket, so because of that it goes down, it's discharged, same like capacitor. Okay, you can imagine like capacitor build up the voltage, and then when it discharge, the voltage gone, current is increased. Okay, current will flow, right? So that's why voltage drop, the current will flow to discharge the capacitor, to discharge the all the charges inside the air pocket. Right. And then so the discharge happens very quick, all right, very quick here. And then because of the voltage across the void, or voltage across the insulation is still increasing. So the voltage is also, after discharge happens, it begin to increase again, okay, until it reach again uz. Okay, uz is where the point is the point where um, the discharge happens again inside the air pocket, inside the void. So it's discharged again. So you can see that the current increase very quickly and then goes down, and then after that it basically the voltage across the air still, across the void, follows the total voltage uh, waveform, right? All right, so this is now, you can see here. All right, so you can see now, um, when when it's now reach the negative cycle. Okay, it's now reached the negative cycle. um, the 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 electrical discharge is now happens on different direction. Okay, when we have positive here, negative here, all right, so discharge happens in, for example, this direction. It's going up, all right, or it's going down. Okay, all right. But when the cycle is now goes to negative, so this is negative, sorry, this is positive, now this is negative. So the discharge still happen, but now it's in the different direction. Okay, so that's why you see here it's in negative cycle. Now it's in a different direction compared to the first one. Okay, so it's a repetitive. Okay, positive cycle, negative cycle, right? So you can see here two conductors or two electrodes in between insulation. This is example of transformer. Okay, so in transformer we have winding. Okay, we have winding. So the winding is copper coil, copper winding, and we have insulation, for example oil, and then we have steel tank. So steel tank, the tank of the transformer is grounded, copper coil is high voltage, right? So we have, if we have for example gas bubble here in the insulation, in the oil, so partial discharge can happen here. We have void between insulation and steel tank. For example, if um, the gas bubble stays here, okay, or latch on the surface of the tank, so the PD will happen there, right? Same thing if the gas bubble trapped on the surface of the winding, PD will happen there. So depends on the location. Okay, if there is a gas bubble or void, that is where the PD will happen. All right, so basically the same thing, the same waveform. This is the total voltage, this is voltage across the void, across the gas bubble, for example. And then if the voltage increase until it reach the breakdown voltage of the void, this is the breakdown voltage of the void, it will discharge. Okay, and then goes up again, then same thing to the negative cycle. Okay, um but let's look at the um for underground cable. Okay, so this is the conductor, this is the semiconducting layer, Okay, we have the insulation, the main insulation, and then we have outer semiconducting layer, um, ground shield, metallic sheath, and armor, outer jacket. Okay, now let's just focus on the conductor, the main conductor, and the insulation, and also the ground shield. All right, so this is where you can see where the two conductors and insulation in between. So the first conductor is the HV conductor. This is the main conductor, and then we have the second conductor, which is grounded, which is serve as ground for the cable, and then in between we have the insulation, the main insulation. And of course we also have semiconducting layer, outer semiconducting layer, but let's just not go into that. Just focus on the main insulation, right? Conductor, HV conductor, main insulation, and then the grounded metallic sheath. So you can see here, if there is a defect during the manufacturing process, all right, we have void or air pocket or cavity inside the solid insulation, and then this is where you can see here, this is the yellow circle, that is example of a cavity or air pocket or void. So you can represent that in this image or in this figure. So we have heavy conductor. C1 is the capacitor of the solid insulation. Okay, cross-link polyethylene. C2 is the void. C3 and C4, very similar concept to this one, right? This is the void. Okay, so C1 capacitors between HV conductor and defect. From here to here, this is C1. Okay, this is from between the HV conductor and the defect or the void, this is C1, and then C2 is the capacitance of the defect, right? And then C3 is capacitance between the defect and the grounded conductor or the metallic sheath. All right, and then the rest is represented as C4. Okay, so this is the total capacitance for this cable, right? Imagine um, imagine that is the arrangement when we have a defect in the cable, or we have and then we will have partial discharge in the cable. Right, so partial discharge includes internal discharges due to the presence of voids, as in solid or liquid insulation, right? There is surface discharge at the boundary of insulating material, okay, and then three in corona, in gas is dielectric, same thing what we have said before. Um, and take note that these discharges, this PD, are not breakdowns, okay? PD is not a complete breakdown, complete failure of equipment. No, it's just partial discharges. Okay, discharge happens only in the void, in the cavity, in the defect. Doesn't happens across the insulation. Okay, across the complete insulation. No, it just happens in the defect. Happens only on the defect, so it's only partial discharge, okay, not full breakdown, right? However, it can affect the life of the insulation, okay. Over time it will affect the life of the insulation, okay. For a prolonged time, the insulation properties of these dielectrics of this insulation could deteriorate with discharge, resulting total breakdown. Okay, for example, this is a cross section of the underground cable, the insulation of the underground cable. You can see that electrical treeing. So if you keep on using the cable, right, the electrical treeing will over time will keep growing, keep getting longer and longer and longer until you will achieve total breakdown. Total breakdown, you will receive basically is a total failure. Okay, ground phase to ground fault in this case, right? So in the example, this is in the stator winding of rotating machine. Okay, we have hotspot, probably um, with winding to ground as well. Okay, okay, let's continue in the second video.